Okay, guys, let's get back to evaluate the model. So previously we were training, if you guys remember, we were training the decision tree using the training data set, so X train and Y train. Now let's get to evaluate the model performance. So we first calculate the accuracy scores, both in sample and out of sample. So for in sample, we will basically be making predictions and of course also calculate the accuracy score based on the training data set. And for out of sample accuracy, we will be generating the predictions based on the test data set and calculating the accuracy score accordingly. So first we create two new variables called as y-train-pred and y-test-pred. So one is we using the classifier CLF, and we use the predict method, and we are predicting based on X-train. So that's our in-sample predictions. And then just make out-of-sample predictions using ACT-test. So again, we are using the predict method of CLF, and we name it the new variable as y-test-pred. Then we also load the matrix module. So that's where we can access the accuracy score function. So from sklearn, we import matrix. Then the in-sample accuracy will just be equal to matrix dot accuracy score function. And then for the first input of that function, that is y-train. So that is the actual labels. And we also put our newly created variable y-train-pred as the second input. So that's a predicted labels. So the first input being the actual labels, the second input being the predicted labels. Both are from the training data set. Then for the OS accuracy, again, the first input of the accuracy score function would be the actual labels, but those actual labels are from the test data set. So that's y-test. And then the second input is going to be the predictions. So that's the y-test-pred. Then we can also print the in-sample accuracy and out-of-sample accuracy using the formatted strings. So we stored the in-sample accuracy in IS accuracy, and we stored out-of-sample accuracy in OS accuracy. Let's execute this cell. Now, we may also want to show the accuracy scores. So here, for the first step of evaluating the model, we are merely showing the accuracy scores. Like in the next few cells, we will be looking at more investment-based performance measures. So as you guys know, that accuracy score is more about how many percentage of the predictions are actually correct. So for the accuracy score part, we still need to calculate the tenfold cross-validation average accuracy from sklearn model selection. So from this module, we are importing cross VAL score and then scores. Remember that this cross val score, because it's k-fold, right? So it's k-fold cross-validation, and you are specifying the k here utilizing the hyperparameter CV. So for this particular function, as long as you specified the value of k, then it's going to return you an array of k values. So in this case, that's going to be 10 values. And the accuracy score we desired is actually the average of those values. So here inside the cross-val score, our first input is going to be our trained classifier, that's CLF. And our second input is going to be the entire data set, for the features. So we don't take the train or the test separately. We take the entire data set for all the features. So that's the second input. And for the third input, again, we take the total data set for the outcome variable. So that's y. And then the fourth input as I said earlier, that's going to be the K value. So that's CV equal to 10. Then for the printing message here, for the printing code here, we are printing the main of the scores. So we are using scores and then taking average using domain. So here, this print message is basically just printing a formatted string with a 10-fold cross-validation average accuracy. So as we can see, those three numbers are quite close to each other. And our model actually has an out-of-sample accuracy that is even higher than the in-sample accuracy. So the thing is that those three values are quite close to 50. So meaning that our classifier is only a little bit better than a random guess. So if you have random guess, your accuracy score is going to be actually just 0.5, right? So our in-sample, out-of-sample, and even the 10-fold cross-validation average accuracy is merely like only slightly higher than 0.5. So that's because like financial data actually has a very low signal to noise ratio, meaning that the financial data set actually contains too much noises. That's why we are not like really able to do a very good job to discover the pattern of our data here. So merely because of too much noises in the financial data. Now, let's also evaluate more about the investment performance. So the accuracy is more about machine learning, right? So it's more about whether the machine learning algorithm gets right or wrong. So here, because we are working on financial data, we are also interested in the investment performance. If we are building a strategy based on the decision tree we created earlier. So now let's do that. So here we were actually using the ML analysis function from our AP module. So what this function does is that it's going to basically doing something similar to quantile analysis. But instead of like treating the data as different quantiles, what ML analysis does is that it will be calculating the average performance of each class. For example, our decision tree will be producing predictions on class 0 and class 1, right? So that can somehow be viewed as the quantiles in the quantile analysis. So what I'm trying to say is that the class 0 and class 1 in our machine learning algorithms or in the ML analysis function is just somehow similar to the different quantiles in our quantile analysis function, again, still in the AP module. What we are really doing here via this ML analysis, again, is just that we are trying to calculate, for example, the average performance of the class 0 portfolio and average performance of the class 1 portfolio. So that's all we wanted to do via ML analysis. Now let's get back to this cell here. So in this cell, we were just creating index for the predictions. So before executing this cell, let me add another cell on top of it. So here, let's see, before we add any index, what does the y-test spread look like? You can see that's just Boolean arrays, meaning that's arrays like composed of true or false. We actually want those values, instead of being true or false, we actually want to convert them into class 0 and class 1. 0 is corresponding to false and 1 is corresponding to true. So That's why here we have immediately following the y-test spread, we have as type int 64. So what that does is basically converting those true false into 0 and 1s. Let me just copy and paste that to the previous cell to show you guys that it's going to be converting the true or false. Let me just add another line. Yep, you can see that does the job. But now we still just have arrays, right, without indexes. So that's why we have to further convert it into PD series. So pandas series. And also we want to specify the index for our newly created series. So let's see what X has index is. That's supposed to be just ID and date for the test data set. Yep, that's just the ID and date for the test data set. So we are just appending that index to our newly created series as an index. And also we are renaming the series as winner. So without converting it into series and without specifying the index names, our predictions on the test dataset will be looking like this. But if we further convert it into series, and also if we add the indexes and we assign the value to this new variable called as OS pred, then OS pred will be looking like this. Of course, I'm just showing first 5 rows. So for the ML analysis, it takes only 2 inputs. The first input is going to be the out of sample predictions. So basically this 0, 1 series here with the indexes. The second input is being the prices. That's the prices for the entire data set. But as a result, we are actually gaining the investment performance for the out of sample period because we are using the out of sample predictions. As for the output for this function, for this ML analysis function, we basically assign those output to two variables, RET, return, and DIA, that stands for diagnostic table. I will show you guys the diagnostic table first. Yeah, that's the diagnostic table. So as you guys can see, the first column is the performance for the class 0 portfolio. And the second column is the performance for the class 1 portfolio. As for the benchmark, that's pretty much just a benchmark or the market portfolio we talked about in the quantile analysis. So that's a benchmark. And then for the active, it's just going to be the difference between class 1 and benchmark. What I'm trying to say is that for the returns, so active return is just going to be class 1's return series minus the benchmark return series. The active strategy here, meaning that you are longing class 1 and shorting the benchmark portfolio. So that's why the mean return of this active strategy is just class 1's mean minus the benchmark's mean. Then for the neutral portfolio, for the neutral strategy, what we do is that we are longing class 1 portfolio and we are shorting class 0 portfolio. So that's why the mean return for the neutral strategy is just a mean return of class 1 portfolio minus a mean return of class 0 portfolio. Let me also show you guys RET return. So that's basically just a return series of our class 0 portfolio and class 1 portfolio, and also our benchmark portfolio, and also the return series of our active strategy or active portfolio and the return series, like the time series of our neutral portfolio, our neutral strategy. Now we can also plot the portfolios. I already showed you guys a return series. Sorry, I will just type that again. So that's a return series. We can sort of calculating the portfolio value based on those return series, right? So remember how we did that? We are just using cum sum. So basically, that's going to help us calculate the cumulative sum at each point in time. We are calculating the cum sum and then applying the exponential function simply because we are using log returns. And also because we want to calculate the portfolio value. Now we store the portfolio values in port values. Then we just plot everything out. So also out of the portfolio values, we are only taking 3 columns here. So we are taking the 3 columns for the class 0 and for class 1 and also for the benchmark. And we are setting the title as machine learning strategy. We are setting the Y label, basically the name for the Y-axis being portfolio value, and the X label, the name for the X-axis being time. So now let's just plot the portfolio value here.